Okay, here's our lesson about hyperbola. We've already learned about hyperbola last semester in Algebra 2, but we're going to look at them from a different perspective this time, kind of like we did with the parabolas, so just look at them a different way. Um, there's the definition of a hyperbola. Again, it's not anything you need to know, but it does start talking about these 2 points which help define the hyperbola, and that is the foci again. So just like an ellipse, there are 2 focuses, so 2 foci. So those are definitely something you do need to know about. There are blank coordinate planes and coordinate planes that are like partially filled out with some information up on the black cabinet. So you would definitely want to gather what you need there. You will need to. We're going to do 2 graphs today, and then also talk about these pictures here that are on this screen. So you want the partially filled out ones. I put some of the information there. Try to save some time for your, since it takes so long as it did yesterday with the ellipses. So you want to get those and put those in your notes. So what I've done on the one that's kind of partially filled out is I've gone ahead and I've labeled a bunch of these points on here for you. So the blue points and the red points and the purple points are all plotted already. I haven't drawn the hyperbola yet. I haven't drawn the asymptotes yet. I haven't drawn these green dots yet. I'm going to kind of walk you through how to do that. Your center should also be plotted there. So, and then over here, I've plotted the points, the purple and the red and blue and the center. But again, I'll talk to you about how to draw the hyperbola and how to draw the asymptotes. So I wanted you guys to do that because it's that doing it yourself will help you learn how to do it. So let's see. So with hyperbola, we have a lot of the same looking things as we did with the ellipse. There's a center, and then there's this a value which gets us out to the vertices. So we see that the vertices are a units away from the center. We also have this b value which gets us out to the what I would call the co-vertices. So it's the co-vertices are b units away from the center. I would have you notice that a doesn't have to be bigger than b now, like it did with the ellipse. So a and b don't have that relationship like they did there. A can be smaller. And then we also have that c value, which gets us out to the foci, or one of the focuses, one of the focal points. So notice how the focus is now outside of a. It's longer than a. That if you think about the way the hyperbola curves, it needs to open up towards the foci. And since the hyperbola open up away from the center, the foci would need to be further away from the center. So that should make sense. And then, so what will you do, once you plot plot your center, and then you figure your a value and your b value, you plot those 4 points, the 2 vertices and the 2, what I'd call co-vertices. What we're going to do next is figure out how to get these green points, because the green points are going to help you draw your asymptotes. And then the asymptotes will help you draw your hyperbola. So what I do to get those green points is I basically just look at where one of the vertexes is, then I run up that line until I hit the same level as the b value. So I just kind of connect that corner there. That's where one of those green points is. Then I go over here to the other vertex and do that same thing. I run up until I hit where that b point is, and I make the other corner. And I do that to the bottom also. So now I move down until I hit where b is, make a corner there, and then do that on the other side and move down until I hit where b is and make a corner there. So once I've got that done, I've got those 4 points plotted. I'm going to use a straight edge now to draw those dashed lines, those asymptotes. So if I set up a straight edge that goes through those 2 points, and then just draw a dashed line, since the asymptotes aren't actually there, but those are those lines that the graph won't cross, as our definition we're using of those. And then if I do it for the other direction, something like that. And again, draw a dashed line through those 2 points, and they should go through the center as well. And so once we have that drawn, those asymptotes drawn, and those do need to cross the whole coordinate plane as you're drawing those, you can use that to help you guide yourself when you draw the hyperbola. So what you're going to do to draw the hyperbola, just go to one of the vertices. So make sure you go to the vertex, not the, you want to go to the vertex, not the co-vertex. You're going to make sure which one is A, which one is B. So make sure you go to one of those vertices. You're just going to start there. You're just going to curve towards the asymptote. So just draw a curve towards there. And then it should just kind of run along there. And you don't have to draw that the whole way, across the paper or anything. I know it's kind of difficult. What I don't want to see is like if you angle towards the, go straight towards the asymptote and then like angle it away. There shouldn't be like a hard angle in this. It should just be a curve. So you can just curve towards the asymptote, and again, if you want to stop a little sooner, then all the way across the paper you can. So just use those asymptotes to help guide your picture. Since there's only one point, we're going to plot for those, just the vertices. And after that, we'll figure out where the foci are, and then you'll plot those points. We'll go through that process later of how to do it, and I'll do that with you. Over here with this picture, this is more about like focusing in on those distances. So I really wanted you guys to see, like, when we have the center plotted, that A is a distance to the vertex, just that idea that's A units away, up and down in this case. Then we have that B value, which is B units and away from the center each direction. And then again, we use those A and B's to plot these corners. So you'll need to do that if you're going to make a picture here. So plot that corner, go to the X, A, and B value, plot that corner. Next A and B value, plot that corner. And the next A and B value, plot that corner. And then use those corners to guide the way you draw your asymptotes, right? Draw those asymptotes through those two corners one way, then draw it through the other two corners the other way. Then again, once you have your asymptotes drawn, you'll find one of those vertices and make sure you're using the A vertex, not the co-vertex, and then just draw a curve towards the asymptote, both directions, and then go to the other one. Draw that. So here we have a vertical hyperbola. There we just drew a horizontal parabola. So just like an ellipse, like a parabola, there are two different orientations for the hyperbola, which means that we're going to have two different equations. Here are those. Notice how similar they are to the ellipse equations that we just did, which can be tricky because they are so similar. It's easy to get mixed up. So we want to watch out for that. One of the main differences you'll notice right off the bat is that now there's subtraction here between the two fractions, not addition. So both of them are subtraction. Notice that A doesn't move around like it did before. A is always first on these. What does move is the X and the H. So for the horizontal, X is first, which should make sense, and for the vertical, Y is first. So what this has to do with is that idea that it's a subtraction, so order matters here. And so that's one of the big things that it's going to be different here. Order is what matters, and that's going to be also for A. Since A is always going to come first, if we notice, look at the two equations, A is always first. It's what it's under that matters. So the order is going to matter for that. So whereas with the ellipse, the size of A mattered. Here it's the order that A is, or the variable it's under. So those variables, that whichever one comes first is the one that matters. So the A value is always under that first value. So A is under X, so A would go in the X direction. B is under Y, so B would go in the Y direction. Now for a vertical one, A is under Y, so A would go in the vertical direction. And then B is under X, so B would go in the horizontal direction. And then the last thing here is the equation to find that focal length. Again, is slightly different. Now this is the Pythagorean theorem, since it's c squared equals a squared plus b squared. So again, just being careful that not to get confused with the other formula from ellipses. Remember, when you guys do take the test, you will have all the formulas there in front of you. But you need to know what A and B stand for, what H and K stand for, or what C stands for. So you really need to make sure you understand what each of these values represents in the picture or in the process. So you don't have to remember the formulas themselves, but you do need to remember how to use them, how to fill them in. So all right, so what we're gonna do is go ahead and do a graph to get me is that this is going to be a horizontal axis parabola, which means it's going to look more like this one here. So we're being asked to graph the hyperbola, give the domain and range, and we're going to make sure we plot the center and the foci. So pretty similar to what we did with the ellipses. What I want to notice first when I look at this is the order of things. So if I notice that x is first, what that would, as I think about this, what it's going to look like when I'm done. What's my picture going to look like? So it's going to be horizontally aligned. So the two hyperbola should open up to the side. So I'm just kind of thinking ahead and make sure when I'm done, does my picture look like that? Okay, so what I want to know from this is I want to know what the center is. And since there's nothing up there with the x and the y, that means the center's at 0, 0. So I'm going to go ahead and plot that. And then I want to know what the distance from the center to the vertices is. So that's a. And of course a is underneath, or a is the first one, so I'm looking at that. I'm looking at that 16, so the square root of that would be 4. So what that means is I'm going to go 4 left and right from the center. So here -4, here +4. I'm going to label those with V's since those are my vertices. I want to highlight those. And then B, my B value is under Y in this case, so B is 3 since it's square root, and that means I'm going to go up and down with B. So going back to the center, 3 up and 3 down. I'm not going to label those points with anything. This text does not label them, so there's all the information I need from the equation. So I'm going to go focus in on the graph now. And so the next thing I want to do is create that box. So what I'm going to do is go to one of my vertices, it doesn't matter which one, and move up until I hit the level of the B point. And then put a point there. So I'm going to have a point right here. And I'm going to go down until I hit that same B value, or the other B value. So point there, go to the other vertex, move up until I hit the level of B, and then move down until I hit the level of the other B. So there's the corners of my box. Once I have those corners defined, I can use that with a straight edge to draw my asymptotes. Again, I like to make sure you draw those all the way across the coordinate plane. Draw the other one. Okay, so once your asymptotes are drawn, you're going to go ahead and draw the graph. And what we want to do that is go to one of the vertices, doesn't matter which one. And again, you're going to curve towards those asymptotes. And again, you don't have to draw it all the way to the end of the page, but for a decent amount. So I'm just going to curve towards the asymptote. And there's pretty much no way that your drawing is going to look exactly like my drawing, because we're only using one point to define this curve. So there's lots of different ways to draw it, but just you can kind of curve towards those asymptotes. Even the two parts of my drawing don't look the same. And then to go to the other vertex, curve towards the asymptote, curve towards the asymptote. So there is our hyperbola. Notice that I go back to my my thought that x is first. That means my parabola should open up to the side. So seeing that it does open up to the sides, like we said, so that's good. So now that I've done that, I want to go ahead and talk about the domain and the range. And we did that the other day with the ellipses and with the circles. So this shouldn't be a new idea. The domain here, remember, leftist to rightist. So as I look at the left side of the graph, I would notice that these arrows are pointing left. So that means it's going to go left forever. So that's my negative infinity. And then it stops here at -4. So from negative infinity to -4, and of course infinity always gets a parenthesis. Here we're hitting -4, so it gets a bracket. And then the graph starts again over here at +4 and then goes right forever. So we would use +4 and then infinity. So there's a gap in the domain. There's x values that we're not allowed to use. As I then want to do the range, as I look at this at the bottom of the graph, the lowest to highest. So as I look at this, there's arrows pointing down. So that means this would go down forever. And then as I look at the graph, it's continuous all the way up forever to positive infinity. So we can say from negative infinity to positive infinity, or you could say all real numbers. So while there are certain values of x that we're not allowed to plug in, we do get every possible number out as an answer. So there's our domain and range. And anytime you do hyperbola, one of either the domain or the range will be all real numbers. Just depends if it's a horizontal or vertical alignment. And then there will also always be a gap in either the domain or the range, depending on the alignment or orientation. So just something about. Last thing we need to do, we did plot the center already, so we still need to plot the foci. So I'm going to use that C equation, C squared equals A squared plus B squared this time. And then we know what A is 4, so C squared equals 16. B is 3, so B squared being 9, so C squared is 25, so C is 5. And so what that means is that I'm going to plot 5 away from the center, but in which direction? And again, C always follows A. So in this case, since our A went left and right, our C values will also go left and right. So going to the center, 5 left, put me a focus right there. I'll label that with an F. 5 right, put me a focus right there. Again, notice how the foci are inside the curves of the hyperbola, further away from the center than the vertices were. Okay, here's the next one. So what I want to do is find the center of that. So make sure you do a sign switch. Oh, sorry, jumped ahead of myself. One thing I noticed here is that y is first. So that means that this is going to be a vertical hyperbola. So when I'm done with it, it should look like this. Okay. So then I want to go and say, okay, well, where's the center of my hyperbola? That's going to be it. Now you're careful here, center. So the x value should go first, -1, and then the y value at 5. So -1, 5. That's my center. And then, so yeah, watch out for that. I'll go ahead and kind of be careful there. So careful with the order. And then we want to figure out what A and B are. So A should always go first. A is always first, and so That means that A is 2, B is always second, so B is 3. So from the center, I'm going to go 2, and now which direction am I going to go 2? So since A is under Y, that means I'm going to go up and down. So 2 up from C, 2 down from C. I'm going to label those with V's. And then B is under X, so that means I'm going to go left and right. So from the center, I go 3 left, and I go 3 right. And don't label those points at all. All right, that's all the information I need from the equation for all, so I'm going to go back and focus on the graph. So the first thing I want to do is create that box. So going from one of the vertices till I hit B value, and then going and doing it the other way, and from the bottom vertex here till hit that B value, and then do it the other way. So you should create that little box. And then once I have that box created, I use that to use the straight edge to draw the asymptotes. So there's one of them all the way across the coordinate plane. There's the other one. So once I have the asymptotes drawn, I'm going to draw the hyperbola. Remember, you start at the vertex, so those ones that you labeled V's, that's why it's important to do that. So it's very easy to accidentally draw it through the other point. So make sure you're using that one that you labeled with a V. And just curve towards the asymptote. This one's going to be pretty wide, pretty flat curve, so just going to watch out here. Again, I don't want you to like shoot towards it, then like angle away. That's definitely something I don't want to see you guys do. So just pretty flat curve. Off to both sides and doing the other one. You know, that quick check, like, does my picture make sense? And so as we look over here at our previous thinking, yeah, it does open up and down like we thought it would. Okay, so the graph is done there. Then we're going to go do the domain and the range. So the domain, as I look at the left side of this, notice that there's an arrow pointing left. So that's infinity, or negative infinity, and it continuously goes right forever. So it's also to positive infinity. So from negative infinity to positive infinity, parentheses on both, or all real numbers. And then the range. So as I look at the bottom of this, I see there's an arrow pointing down, so that's going to go down forever, but then it stops here at 3. So from negative infinity to 3, bracket, and then starts up again at 7, and then goes up forever. So from 7 to positive infinity. So what this means is that we can plug in any number we want. Absolutely every number can go in, but we'll never get an answer between 3 and 7. So we get like negative 10 as an answer, we get 2 as an answer, we get 3 as an answer, we get 7 as an answer, 10, 1,000 as an answer, but we would never get 4 or 5 or 6 or 6.5. Those will never be answers. So there's our domain and range. Last thing we need to do is, since we already plotted the center, we need to plot the foci. So again, c squared equals a squared plus b squared. So c squared, let's see, what was a? A was 2. So 4. And then b was 3, so 9. So c squared equals 13. So c equals the square root of 13. And we do need a value for that since we need to plot it. So let's see what that is real quick. But know it's somewhere between 3 and 4. So 3.6. And then that's the direct distance we're going to go, and we need to think about the direction we're going to go. And remember, A follows A. So that means this ARA up here went up and down. So I'm going to go from the center, 3.6. So 1, 2, 3.6-ish. There's the focus. 1, 2, 3.6-ish. There's my other focus. So there's our graph, our domain and range for our hyperbola. I will do another video talking about how to write the equation. So you can look for me there. Towards the of a hyperbola.